Section 4.8, Applications of Polynomial Equations and Functions. A second-degree polynomial equation in one variable is often called a quadratic. To solve quadratics, we need the zero product rule. For any real numbers a and b, if a times b equals 0, then a equals 0, b equals 0, or both. So when you multiply two numbers together and you get 0, then one of those numbers has to be 0. So we need to factor this to make it a multiplication problem. We put our double set of parentheses, we factor x squared, we look at the sign before 36, it's positive, that means the signs are the same. They're the same as the middle term, which is positive 13. So we know we have a plus and a plus. What factors of 36 will give us an outside plus inside of 13x? It's got to be 9 and 4. So now we've written this as a multiplication problem. We have the product of these two numbers equal to 0. That means either x plus 9 is 0 or x plus 4 is 0. Well, what makes x plus 9 0? Negative 9. What makes x plus 4 equal to 0? Negative 4. So in general, to solve an equation using the zero product rule, we want to get 0 on one side. We have to have 0. Simplify the other side. Factor the other side. Set each factor equal to 0 and solve the resulting equations. So let's look at this problem. Solve x squared minus 3x equals 54. We don't have equals 0. We have to have equals 0. Let's subtract 54 from both sides. That gives us x squared minus 3x minus 54. Now we want to factor. How do we factor? We need an x and an x. What are the signs? Which factors of 54 do we want to use? 6 and 9. And which one is positive? So that gives us x plus 6 equals 0. X minus 9 equals 0. X equals negative 6. X equals positive 9. So we have two solutions to our equation. We don't have equals 0. We have to have equals 0. I prefer for my x squared term to have a positive numerical coefficient. So I'm going to get equals 0 by subtracting 5x from both sides. Then I have positive 3x squared. I'm looking for a common factor here. Do you see the common factor? When you factor it out, what's left? Set each individual factor equal to 0. So we have x equals 0 as one solution. Look at this, 3x minus 5 equals 0. Be careful when you're solving equations like this. A lot of times I see students try to solve them just in their heads. They don't want to write anything down, and they make a mistake. They usually end up with the reciprocal of the answer. The answer should be 5/3. So you have to add 5 to both sides, divide by 3. That gives you 5/3. Take the time to write down those steps. This one looks like it's been factored, but the problem is it doesn't equal 0. So this factoring here does nothing for us. Let's multiply it out using the distributive property. That 48 is doing us no good whatsoever. So let's subtract 48 from both sides. What next? How about we factor? What are the signs? Which factors of 48 do we want to use? 6 and 8, and which one is positive? So now we set our individual factors equal to 0. We solve the resulting equations. And that's it. That's our solution. Given that f of x equals 8x squared minus 6x, find all values of x for which f of x equals 9. F of x is 9, so instead of f of x here, we're going to write 9. That looks a lot like a quadratic. We don't want that equal 9 there. We need equal 0. Let's subtract 9 from both sides. Can we solve this? Can we factor it? It could be that it's 8x times x, or it could be that it's 4x times 2x. Which is it? What are the signs? It's minus 9, so we need a plus and a minus. Where does the plus go? Where does the minus go? We don't know. So we just have to guess and see what happens. What are the factors of 9 that we want to use? 3 and 3, or 1 and 9? You have to experiment and put them in both ways. I think we need a 3 and a 3. Have we got the signs right? That gives us minus 12x plus 6x. That's minus 6x. That's right. So this is our factoring that we need. We didn't need the 8x and the x. So we need to set each individual factor here equal to 0. For x plus 3 equals 0. For x equals negative 3. Divide by 4. X equals negative 3/4. 2x minus 3 equals 0. Two x equals 3. X equals 3/2. So we have two solutions there. Find the domain of the function given by each of the following. So we're looking at domain, allowable x values. We cannot allow division by 0. So one way to write the domain, or to think about this, is to realize that denominator, that x squared minus 4x minus 5, cannot be 0. We cannot have division by 0. We can factor this. X minus 5, x plus 1. So now we set the individual factors. They're not equal to 0. So that means that x cannot be equal to 5. The second equation tells us that x cannot be equal to negative 1. So that's our domain. All x except 5 and negative 1. We cannot have 5 and negative 1. Look at this fraction. We cannot have division by 0. We don't care if x is 0. That's fine. We never are bothered by the numerator being 0. It bothers us when the denominator is 0. So 6x squared minus 54 cannot be equal to 0. There are different ways to solve this. You can factor it, or you can just add 54 to both sides. So 6x squared is not equal to 54. X squared cannot be equal to 9. So x cannot be equal to 3. There's another one, negative 3. Two numbers that we cannot include in the domain of this equation, this function. F of x is 1 plus x over 9x squared plus 30x plus 25. Once again, we don't care if the numerator is 0. That's not a problem at all. But we do care if this denominator is equal to 0. It cannot be 0. Does this denominator remind you of anything? This is a perfect square. This is a perfect square. This is a special product. If you realize this is a special product, it's faster to factor. It's actually 3x plus 5 quantity squared. That cannot be equal to 0. You can use FOIL in reverse if you want to, but if you realize it's a special product, it's much faster. So 3x plus 5 cannot be equal to 0. 3x cannot be negative 5, and x cannot be equal to negative 5 thirds. So the domain consists of all real numbers except negative 5 thirds. X cannot be equal to negative 5 thirds. So that's the end of section 4.8, part A. If you want to see the second part, the application problems, go to 4.8, part B.